Good morning, good afternoon, everyone. This is Dr. Yang Ping, DTG Deputy Chairperson. I'd like to welcome you to this session. Before the meeting, I'd like to thank to the BML for the arrangement. Let's begin by reviewing the agenda for today's meeting. We will have two reports by Dr. Jisa Foya and Dr. Xiongxing Chang under the topic Machine Readable Information in Metrology. Each report will be around 20 minutes, and the 10 minutes discussion are just after the report. The topic of first lecture is Digital Certificate of Conformity in Metrology, presented by Dr. Jisa from PTB. Dr. Jisa received her doctorate degree in civil engineering from the Technical University Braunschweig in 2013. She is a researcher at PTB and has worked in the Department of Solid Mechanics until 2018 as a postdoc researcher and a project manager in the fields of force and torque measurement. In 2018, she became head of the working group Communication Technology of Weighing Instrument in the Department of Math. Her work includes software testing on weighing instrument and the digitalization of calibration certificate for weights and mass. She is the lead of the Noble Math Project Group Digital Certificate in Metrology. So please, Dr. Jisa.
Thank you, Yang, for this nice introduction, and thank you very much for giving me the opportunity today to speak to you in this OIML DTG webinar. In the next 20 minutes, I'm going to tell you something on the digital certificates of conformity in metrology. And you might just add a legal in brackets in there because I'm focusing on legal metrology and the certificates we use there rather than industrial metrology or any other form of metrology. But before I start telling you what we actually do in this project and in my project group here, I'd like to give you an overview of our project framework. So we work in a German initiative, which is called QI Digital, which stands for Quality Infrastructure Digital, includes several other German, first of all, research institutes, but also the German accreditation, as well as the standardization bodies. And this is quite important because we use the definition of quality infrastructure that it is actually the addition of standards, metrology, conformity assessment, accreditation, and market surveillance. And this definition is not new. It has been established by INET QI, so it's based on INET QI definition, which is the International Network on Quality Infrastructures. And when you look into the members list, you will find that OIML is a member there as well. So I think it's quite fitting that I can present this topic to you today. So where do we actually stand in this project framework? The framework has several use cases. The colleagues are dealing with artificial intelligence in medicine and also additive manufacturing, but you will find the digital certificates of conformity in the use case hydrogen refueling station. So the refueling station itself is a measuring instrument. It's actually based on an OIML recommendation, and there we are dealing with certificates in conformity assessment. I think this much was clear, but now I'm going to give you a more detailed look on what we are focusing on. So there are several ISO IC standards dealing with conformity assessment. There's ISO IC 17065 based on product certification, and that's what we normally use for type examination, or some might call it type approval. For example, in the OIML-CS, you normally call it type approval. But you can also use this standard for quality assurance of the production process as well as product verification. And in the European Union, we have certification systems. These are fairly, based on ISO IC 7067, so not completely based on that, but they're very similar to what was set up there. We deal with the European directives MID, Measuring Instrument Directives, and NAVIT, which is a non-automatic weighing instruments directive. Fortunately, both have the same structure. So we have a modularized product certification, as I said, with type examination, followed by either quality assurance of the production process or product verification. Those of you from the European Union might know them also as module B plus D or module B plus F. There are other modules which we don't focus on because it's quite too difficult to harmonize all at once. You see there's a bit space left on the slide, so we can see it is possible to fill in an international level as well. And here OIML-CS is an important step because the type examination or type approval in this case of OIML-CS can be used for EU type examination by several of the issuing authorities within Europe. So overall, what we're doing in this very big framework on digitalization of the quality infrastructure is we'd like to focus on digital certificates of conformity, especially those you see here on the right side, meaning type examination, quality assurance, and product verification. To give you a better overview of what are our main objectives in the project, I have another slide to just sum it up. So first of all, we'd like to discuss and analyze the data structure. I will be talking a lot about data structures in the following, 15 minutes. And I hope at the end we have this common understanding of what a data structure is. But generally, we are trying to analyze certification information for conformity assessment according to, as I said already, Measurement Instrument Directive, Non-Automatic Weighing Instrument Directive, and because sometimes legal issues do have borders, national regulations. So in case of the hydrogen refueling stations, for those of you who know a bit more, this is actually nationally regulated currently in Germany, but will most likely end up in the MID in the following 1 or 2 years, if I'm correctly informed. So we see here very much that the systems really sometimes have borders which can be dissolved quite easily as well. A second step that we want to take, because this, first of all, to underline it again, this data structure is analog, so we have to turn it in a digital way afterwards. So we are talking about software and tools. And the first step there is to make this data structure, that is a theoretical construct, machine readable. This is a digital data structure. And if we're talking about machine readable documents, certificates, we actually need tools for creation, altering, and viewing, because Word will most likely not be useful here, at least not completely. Another point that is really important, you've seen now already we have a European approach with an eye on the international level. So we need some kind of standardization. So our goal was to have a draft of standard for this digital data structure. I'd like to just stress how much it doesn't have to be a formal standard. So we're going for anything that can be used as a documentation for this structure. So where did we start? It was said in the introduction of myself. We started first of all with the data structure. Sorry, I forgot this one. And then we started on a European level with the NOBOMET. NOBOMET is the notified bodies in metrology. This is the European coordination group for conformity assessment bodies for measuring instrument directive and non-automatic weighing instrument directive. This is comparable to a bit of OIML-CS management board or the entire system about OIML-CS. So this is all notified bodies, which is in OIML terms, issuing authorities that come together and discuss issues that are relevant for all of them. And there we established a project group back in 2021, so already 3 years ago. And we said already that the lead of this project group is with me. And our aim is quite luckily the same that we set for our project framework. So the objective is to get a data structure for certification information, especially for type examination, but also for quality assurance of the production process, as well as product verification. So we managed to line up our goals in the project with the project group, so we can actually start harmonizing on the way to the development of a data structure. How does it look like? How do you set it up? So one of the things we found, not at the beginning, but really I think about 2 years into the project, is it's quite difficult to account for so many different certificates. Even if you're only talking about measuring instruments. As I said, you have type examination certificates, you have other certification systems such as OIML CS, and you have product verification certificates. They look completely different. So at one point, one important step was to decide that it's a modular system for the data structure. So our structure doesn't consist of one part, but of several. The main part being the DCOC certification data. So this is the main certification data, and this will be the focus of today's presentation to give you a glimpse into what we're doing there. But it is accompanied by some additional information. First of all, the possibility to give comments, but also to have a result to that, because depending on the certification system, the detailedness of the results is quite different, especially also from country to country, you find different results. So the idea was to have a modular approach here and say, okay, for each of the system, we need a specific result part. For Novomed, this is the type examination. So we call it here DCOC MB, where M is for metrology. So in the European Union, we have a metrology marking, which is just a single M. And because it's a conformity assessment module B, we called it MB. So if you see the other ones, you might have a guess what these could be. Then this is ready in a first draft, but I'm not going to tell you much about this today because it would be a bit too extensive. But looking into this first part and this blue puzzle piece, the universal certification data, what is it? Basically is a representation of the main part of the certificate. This main part is often the first or the second page or the first 2 pages, but it's not really limited to pages. Sometimes you find information that is very relevant on the last page, for example. What you can see here as a depiction is the WELMEC Guide 8.3, which includes a template for the EU type examination certificate. It was lucky for us that we could actually start with a template, a European approved template, more or less, for all the general certification data, which is already used for all products and certificate types. Here, all more product types, but we were going for certificate types as well. But it's nice to have a start. So then the question always arises, and how do you define a data structure from this? So we have a template, we have an idea of what we want to achieve, but the question is how to get there. So first of all, the idea for data structures is always to have, to identify content components. This can be addressed, it can be the name of the certificate, in this case, EU type examination certificate, or it could be the recipient of the certificate, which is mostly the manufacturer in our cases. These then equal elements of the data structure. So we try to dissect the information into smaller pieces. And then we have to name this element. So we here in this case said, okay, this is DCOC manufacturer. This is, if you look directly, the reuse of the specified designation according to the new legislative framework. This is the basis on the European level, but it does not work with the ISO IC 17065 wording. There, they normally talk about clients. In the standards world, you find words like clients or customers, while in the legal metrology world, you normally find manufacturer as the first one to address. So we said, okay, because we are still working in the digital certificate of conformity in metrology, we chose the DCOC manufacturer for this element. This is just an example. So there's elements that come easy with the naming, and there's elements you discuss a lot about how to name it, so it's getting easier. What you can see here is, first of all, this is the entire machine readable element. So this does not change. It always describes the same content. And it consists of 2 parts. First of all, we have this content component of the certificate. I already told you how to deal with the word of manufacturer, but it also has a prefix. This is unique to a reference to the data structure. So for example, if you compare it with the definition you find in ERA manufacturer, this is on railway specifications. It's also an existing vocabulary. You find that it might differ from this one. So we have to set a surrounding area where we say, okay, within our DCOC world, this word means something. And then we come to the second part. So we have to define elements and we have to define meaning. So how is the data element defined? So what is behind this DCOC manufacturer? So the first part, I know most of you do standardization work. And it's always very, very tedious to discuss wording, to discuss terminology. But in the end, you do need them because otherwise you don't know what you're talking about. So the first part we're doing is the definitions part. In this case, we took the definition for manufacturer as being shall mean any natural or legal person who manufactures a product or has a product designed or manufactured and markets that product under its name or trademark. It sounds very formal, and it is. It's from the European Union. We copied that definition because we're working in that framework. But it's easier to understand it. We're going into this a bit more in the following slides. That sometimes it's easier said someone is the manufacturer, but who is actually manufacturer is sometimes not as easy. So in this case, we might not use it, but in general, we have a label. This is a display for the user in our data structure. Manufacturer is easy. Sometimes you have abbreviation in element names. So it's quite difficult to guess what the abbreviation means. Sometimes you have to shorten the element name just for shortness purposes. So it makes sense to have an element name for the user, which is then the label, and it gives you the opportunity to have language sensitive labels. So I could also use this in German and say my German label would be Hersteller. The element is still called DCOC manufacturer. Another piece of information that we often give to our elements is the attribute. As I already said just now, sometimes we have language sensitive information, so we have to give the information of which language this information is in. So we have to say this is English, this is German or French. And sometimes we have to reference information, therefore you need identifiers to reference them to each other. A piece of information that is often forgotten or just referenced in some sentences is the cardinality. This is an information about multiplicity, and it just in short terms, it says first whether something is optional or obligatory. So do I have to have this element? So for example, I do need a manufacturer in the certificate, but I might not need all the other information. And it also gives the information on whether an information is singular or multiple in entries. So I had the discussion before. I thought we only have one manufacturer, but I already found cases where we might have several manufacturers. There you might have done several, but for example, you only have one certification body, one issuing authority, and not several ones in one certificate. The last piece of information is the data type. So this is really focused on machine readability, but in general, we humans need that as well. So I need to know whether this manufacturer is just a string of a company name or whether this is contact information. So it's a complex data type in this case then. Other examples of simple data types, except from strings, are, for example, Boolean or integers or dates, which is the most common one, I think, to have a date or several date in certificates in there. For the complex data types, you will find another element description in there. So here we have in very small, for example, the DCOC contact. For all of you who've seen the DCC, we copied a lot of the standard information from our colleagues from the DCC team because it doesn't make sense to redefine contact. So we copied it in here and we use it, for example, for manufacturer. So because this is quite tedious to read, if you have to explain it, all those small elements by themselves, we actually achieved our third objective more or less already because we wrote a specification for this data structure. We wrote it down, noting motivation as scope, as well as some general principles. So everything I've just shown you, we tried to write down. So what is an attribute and what is cardinality and how to note it. And we actually defined all those elements that we found important for DCOC. And as I coming back to, this is Novomed work. So this is a committee work in the notified bodies of metrology in Europe. We have published this in May 2023 as the first document of Novomed. Novomed isn't that old as a committee, but I think we are quite proud that we already achieved that first part to have this part published and usable. And there's a question, usable for who and how? I'd like to just address those things now to see, okay, where could we use this? One of the questions for this group, I think, is would it be possible to have an DCOC in OIML? And the first step in this process is always to put it next to each other and see, okay, do the templates match? Is the information similar? So on the left side of the slide, you find an EU type examination certificate according to the WELMEC Guide 8.3. And on the right side, you find an OIML CS certificate template from OIML CS. And you can see that we have information that is basically identical. So having a certificate number is something that is really, really common between all certification systems. They might not look the same, but they actually have a number. We have information that is similar. I'm coming back to the manufacturer because in OIML CS, you have the possibility to give applicant and manufacturer. Well, in the European world, you have a manufacturer and an authorized representative. An applicant is normally not mentioned on the certificate. There you find really small deviations, which might not be problematic because I think it's possible in the data structure to say, okay, you have a manufacturer and you have maybe additional persons related to this, and you can just define that role. But there might be coming up some changes to make a DCOC working for OIML better than it is now. And we have a few information that is actually different from one to the other. I've just shown snippets. There's more information that's not completely the same, but just to give you a feeling here. For example, the validity is completely different in the certification systems. But as we already have very different versions of validity, so a type examination certificate EU version is valid for 10 years, while a product verification doesn't have a validity. So this is not actually an issue. This is just an example that we already have covered. So I'm remaining in a bit in the practical world here, just saying, how can this look like? So for all of you who have never seen a digital version or machine readable version of any certificate, this might be new. For those of you who might have seen DCCs, for example, this is something that's quite common. I just put it in here as an example. So for PDB, we'd like to do our DCOCs in XML because we're using them in the DCC already. The specification is written independent from this, so you could use it with JSON or any other format. And I'm giving here you now just a glimpse into how this could look like. And if you look closely into the slides, you will find the same element names here. Okay, I haven't done the manufacturer in here. I think I should have copied that one. You find here certification scheme and certification body as main information. And on the right side, what you can see is not the OIML CS template. This is actually an HTML version from that one, which is generated from a DCOC. So this is already possible to give at least a rough layout of templates of existing certificates by our data structure. The other part, apart from can I apply it and how does it look like, is always, does the process change? What actually changed in the working process here? And that's why I brought the slide to say, how does it work in general? And the easy way is the same. So we still have a manufacturer that manufactures a measuring instrument. We still have, at least in the OIML world, an issuing authority that will check it, evaluate it, and give a certificate. This certificate will look most likely for the manufacturer still the same, because most humans still at least want to have a copy of a human readable version. But especially for the OIML CS database, it makes sense to use a digital version because we don't have to feed it to a human to feed it to a database. That's what we're doing now. But it would be nice to adopt here the digital version and say, okay, can't we just automatically import this? So at the end, we can have the same users of the database. So here it doesn't change. It really just changes in the small part in there. So how does it work? As always. So it doesn't really change that much. It always changes a few small things. And it always now sounds like, why are you doing all this for just this small step? This is translatable. So this doesn't only work for OIML. This works for European certification systems. And this does not only work for measuring instruments, but technically for all certification systems. We're working here at PTB with our colleagues from IECX, from Explosive Atmospheres, and trying to get this down in the world for other things as well. And I'm coming to my last summary slide, just to remind you, what have I told you, or what at least I tried to tell you? What are our goals? We'd like to get a data structure for MID and NAVID, so the measuring instrument directives of Europe. We'd like to have the digitization of those contents, and we like to have software for handling at the end. What are the benefits? The benefits of such a digital template is it's a universal template. It can be used for hopefully a lot of certification systems, and it allows for automatic processing as well as machine actionability. So we have a lot of small steps that we can take from here on. And to coming to our success stories, what did we achieve until now? So we have it published. It's first step to having some kind of harmonization. We have a modular approach, which hopefully gets us through a lot of other applications and makes it really fit for a lot of purposes. And we hope to continue those success stories in the future. And with that being said, I'd like to give some thanks to, first of all, the NovoMed project group, because I'm just the lead. This is not possible without others working on this, as well as to my project team here at PTB. And I would give the floor back to Ping Yang for questions and discussions. Thank you very much.
Thank you, Dr. Jisa, for your very comprehensive presentation. And I think we can have a short time discussion on this report. So if anyone you have questions or comments, you can just raise your hand. So Dr. Jisa, can you maybe stop your slide? Okay. Are there any questions or comments?
I don't see any hands up. So.
Okay, please.
I think you have one hand up. It's Su. Go Su.
Okay.
Hi. Hi, Tisa. I just wanted to know what are the technical requirements for the DCCs?
At this point, the DCC is a DCOC, sorry, is a data structure. So it's just a specification. You can actually choose your own software development or software environment that you can use for it. In XML, the requirements, the basic ones, are easy because it's just an ASCII code, you can read it. So there's not much of software requirements. If you go for the development, for example, to integration into, for example, an automatic import in a database, it depends on your database. Normally, those already have interfaces, so the requirements are not that high. So you have to specify which information goes where. And the benefit here is from sorting the information and less from actually having a lot of requirements in there. So small software requirements.
Okay, thank you for the question and comments. Are there any questions? I think Dr. Jisa's report is very, maybe something is very new for most of us. If there is no further question or comments, I think if you have questions or comments after the webinar, Dr. Jisa already showed her email in the last slide. I think you can contact Jisa or contact the DTG for further comments or more information after this presentation. So if there is no further questions or comments, I think we can go ahead for the second report. Okay. The topic of second lecture is research and okay. The second report is research and development progress of DCC network service in named China, presented by Dr. Xiongxing Chuang. And Dr. Xiong is the director of the Center for Metrology Scientific Data of NIM China. He is also member of the International Measurement Confederation Amico TC6 Digitalization, and also member of the Digital Transformation Focus Group of the EPMP. And Dr. Xiong, can you share your slide?
Thanks, Dr. Yang. I will share my screen. Okay. 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 Good morning and good afternoon, everyone. I'm Xiongxing Chuang, Acting Director of Center of Metrology Scientific Data, NIM, China. And the topic of my report is research and develop progress of DCC in NIM. My report has 6 parts: DCC metal model, DCC generate and verification tool, ontology of term in DCC, digital security and identification for DCC, DCC network service system and preliminary application of DCC. And term 1, DCC data model. When we developed the DCC meta model, we followed 3 main principles. First, for reference to PDB's meta model structure and terminology, trying to align the DCC meta model of NIM with the model of PDB. This means that on the basis of PDB's meta model, developing NIM's meta model is an addition operation, not a change operation. Second, language comparability is very important. So the meta model using Chinese and English to express calibration information. Third, attach great importance to iteration and update meta model variants. This is the connect of the latest version of NIM DCC meta model. The model structure is same as PDB's. The model contact is ratified by NIM, and the NIM gave the reference website. NIM developed the website to explain DCC meta model and examples, and also provided different variants of the meta model for download. And the NIM DCC has passed TRISM certificate by PDB, which is a technical functionary for international mutual regulation. Item 2, DCC generation and verification tool. We have developed a web-based tool for generating DCC file. With this tool, we can fill in the calibration information step by step using generating DCC file. Moreover, we have also developed a DCC file verification tool. Submit an XML file on the web page, just whether it is qualified a DCC file, and give the version numbers of its model. Item 3, research on ontology of terms in DCC. It is very important that calibration information can be understood and interpreted by the machine. Therefore, we attach great importance to the study of ontology and the digitalization of vocabulary and item in DCC. Digital representation of units in DCC using the digital SI model. The digital SI model is the output of a Euromatch SmartCom program. We developed a meta model of DSI, digital SI on this basic. We also study ontology of United terms in Vim. Wrote a paper entitled Vim Research on OWL, Basic Vocabulary Ontology Construction Method for Units of Measurement, and published it in the journal Electronic. In order to realize machine understanding of measurement item in DCC, we developed ontology of measurement item, wrote a paper entitled Design and Implementation of Ontology for Measurement Terminology in Digital Calibration Certificates, and published it in the journal Sensors. This diagram shows the relationship between the core conceptions of measurement items. We are studying how they unite terminology of digital SI in DCC can be tracked back to the SI reports, so that to realize machine traceability. Item 4, digital security and identification for DCC. The digital security of DCC includes 3 parts: digital signature, trusted timestamp, and DOI, digital identification. DCC's digital signature. Digital signature provides integrity, message authentication, and senior authentication for data in DCC. Under the special namespace, DCC XML signature contains the signature element. This format can be used to digitally sign the following entities: calibrator, assessor, approver, and certificate issuing agency. The digital signature adapted by DCC is an advanced electronic signature standard based on XML, which is widely accepted and applied, and meets the requirements to law and regulation on the electronic signature. This slide is used to explain the digital signature element, SIG info of DCC. A safe and credible DCC leads trusted timestamp to issue its information security. So we have developed the reliable and accurate timestamp service traceable to UTC name with time traceability to UTC and contain the time uncertainty data. We have developed the progress and the software of timestamp for endorsing DCC. We can verify the timestamp of a DCC file online. We can query the endorsement information on the timestamp of each DCC online. When we developed the Chinese DOI identification function of DCC, so that DCC files can be findable. Next, we will develop software to enable DCC files to comply with the file principle. A DCC file that has a register with a DOI can be retrieved on the Chinese DOI website. This picture is an example found on the Chinese DOI website. Item 5, DCC Network Service System. As shown in this picture, the system includes two parts: the DCC Network Service System and the Digital Security System. The design of DCC Network Service System is divided into 5 layers: access layer, application layer, interface layer, service layer, and resource layer. We have developed 2 types of application system to using DCC Network Service System: web-side wizard DCC application and digital calibration application. The website wizard DCC application are a guide model, and the interface is friendly. The interface of DCC service system are web reference RESTful API. This interface can be direct invoked by computer. The RESTful API is registered in the API gateway at the interface layer and explained using the Open API Swagger. Make it easy to custom to call the API. Item 6, preliminary application of DCC. On the digital terminal, we have realized the network calibration of time as the picture shows, using NTP protocol to realize time network calibration and use time calibration web service to generate DCC. We have developed the digital generation of DCC through NTP protocol network time calibration, and the system calibrates 4 devices every day, and more than 2,700 DCC files had been generated. We also developed time frequency calibration to generate DCC based on GNSS. This system calibrates time frequency of 16 devices and generated more than 1,800 DCC files. Another calibration is that we store DCC files on RFID, and RFID is pasted on the instrument. In this way, accurate and efficient application of instrument calibration data can be realized in blacklight library or unmanned factory. We are developed more DCC application. That's my report. Thank you. Thank you all. Welcome to ask questions. Thank you.
Okay. Thank you, Dr. Xiong. And Dr. Xiong display the DCC solution and progress in China. And based on the domestic requirement, he also displayed some solutions, some application, such as the signature trusted timestamp, and also the DCC in the time and frequency fields. So thank you, Dr. Xiong. Are there any questions or comments for this report? If you have questions or comment, I think you can turn on your phone.
Hello, Dr. Xiong. So can I ask, what are the future challenges facing the implementation of the DCC?
Thank you. The challenge of DCC is how to apply the DCC file to the instrument, and how to apply the DCC into the instrument. It's very difficult to get the interface of the interface and API from the instrument. And there is a very different, many instrument to calibration. Okay, thank you.
Okay, thank you. Any other questions or comments?
Morayo?
I think yeah.
Yes, thank you very much for both presenters. Well, I just have a general question, really. And the work you're doing is very important. So are you working closely with for example, international bodies like the BIML to see how your work can be used in the international metrology standards development area? Or are these just projects that you're conducting individually in your countries? Okay. And my question is addressed to any one of the speakers.
Yeah, I can start and answer from myself. Thank you, Morai, for that question. For us on the European level, so it's not just national, for the DCC on the European level, Nubomet was identified as the right committee. And for the international level, we are trying to get in touch, or we're starting talks with the OIML-CS world to see whether this would fit in there as well. So we're trying to make this work for a broader range of people than just our national requirements.
Thank you.
Okay, thank you. In the chat box, Dr. Xiong, the colleagues from Yunnan want to know if we have issued a DCC for time and frequency already.
Time frequency. Okay.
Okay, I think you can turn on your camera.
Oh, camera. Okay. Sorry. We developed the time frequency calibration to generate DCC based on GNSS protocol. This system calibrates the time frequency of 16 devices. And we have generated more than 1,080 DCC file, and make another digital calibration software for based on NTP protocol. And the system calibrates 4 devices every day. Okay, thank you.
I wish Dr. Xun answered the question from Yuan. Maybe in the time and frequency fields, it's much easier to accept the DCC, firstly. So another question or comment? And if you have maybe not questions, I think based on the 2 reports, you can maybe have some comments, maybe explain or display some requirements or some progress in your countries or in your institute. Okay, I didn't see any hands. So I think we are ready to have your information or questions after the webinar. Or you can send your comment or questions to the reporters or to the DTG or to BML. So if there's no question or comment, maybe I think we can try to close the meeting. It's near the end of the meeting. I'd like to share some information of the next meeting. The upcoming meeting will be the late July with the topic of digital technologies for processes in legal metrology. And also, we will invite BML to issue the invitation with more details later. So please keep eyes on your email. Till now, we already invited 3 reports. The colleagues from India, from Switzerland, from Europe Union. So if there's no question or comment, I will close the meeting. And firstly, I'd like to extend a special thanks to our 2 speakers, Dr. Jisa and Dr. Xun, for your sharing your expertise, your insights, and your application, provided us with a new perspective and opportunities for the DCC. And also, I'd like to thank all the participants for your attention. And I wish maybe in the next webinar, you will have more questions or comments. Just show your consideration or show your comments towards the digitalization. So if there are any additional thoughts or follow-up points after the meeting, we feel free to can have your or receive your comments and questions by email. So once again, thank you for your active participation, and see you next time.